All right, our recording started. Welcome everybody to the first in a new Tech Talk series. We're rebooting a past series that was started at the beginning of the EdgeX Foundry, where we did a series of roughly hour-long videos talking about different aspects of the projects, helping you learn about it, learn how to get involved, and how it all works together. A lot has changed since the project started a year and a half ago, so we've decided to reboot this series, starting with the very first one. So we're going to do a getting started guide today. And with us to give the presentation is Jim White. He's a distinguished engineer and lead of the IoT platform development at Dell. He is the founding architect for the EdgeX Foundry project itself, which started as a Dell project. And he's currently the vice chair of our technical steering committee. So he's going to take us through the presentation. At the end of it, we're going to have a little bit of time for questions that you might have. So if you think of questions during the talk, if you want to type them into the chat, we can get to them later, or just wait until the end. We'll open up the microphones to anybody who has questions and try and answer as many of those as we can. This is going to be a recorded video, so after it's done, we're going to host it on our wiki. It's wiki.edgexfoundry.org. So there you can rewatch it, or you can share it with other people inside your companies who are interested in it. We're going to try and do these every 2 weeks. So watch the wiki page. The schedule is going to be on there. We also have a newsletter. If you go to edgexfoundry.org and you scroll all the way to the bottom, there's a form you can sign up for the newsletter. We can reach out to you there. Also follow us on Twitter. We are at EdgeXFoundry on Twitter. So follow us there, and we announce these and future Tech Talks there. And with that, I'm going to hand it over to Jim to start the presentation.
Thanks, Michael. Appreciate it. And good afternoon, good morning, good evening, depending on wherever you all are. So if you could, in the text chat window, just so we can start to kind of get you set up to use text chat, just give us a little indication of where you're calling in from today. Will help us kind of get a better understanding of where people are from out there who are listening in and paying attention to EdgeX, but also allows you the chance to use text chat so that if you have questions as we roll through the material today, you are welcome to type those questions in there. At the end, as Michael said, we'll also provide a time for Q&A where you can pipe up on audio as well. But we'll try and get through the material and take your questions as we go through chat. Michael, thanks again for the introduction. The only information that I'm going to cover here on this slide is to point out my email address for everyone. So you are free to send me emails at the address you see on the screen there. Happy to try to answer your questions, or probably more appropriately, I will point you to a person in our community that's getting quite large now, and have them help you out, as we have various members across the world helping us on all aspects. EdgeX and the expertise is now quite literally dispersed across the world. So we'll get you pointed in the right direction with the people who are working on the area of your question most directly. And I guess I will also offer up an apology. As Michael said, I was one of the people who helped found what was Project Fuse in Dell and became EdgeX. And so, yep, some of the lines of code you see out there in the material that we'll kind of be covering today, some of those are mine. Apologies in advance. I am going to defer to much better expertise in our project going forward as far as the code is concerned. Michael also covered the points about our text talks. We started these back in 2017 when we launched EdgeX, but we are updating now, in particular updating it because most of our services have been changed from what was a Java code base largely to now largely Go base. But we welcome any kind of suggestions you have. So please feel free to email me, email Michael, and we'll provide some information at the end about that so that you can give us the topics that are of most concern to you. Now, today's Tech Talk is very much introductory, and that is we do not assume that you will have any kind of background or very little background on what EdgeX is, about Docker, or any of the tools that we're going to be talking about here today. And you'll find that for the most part, the instructions we provide you are step-by-step guides and don't really require you to know much about the Docker or Docker Compose or other types of environments that we'll be using. Future Tech Talks will go into quite a bit of detail, but today's is really for, as we like to say, the newbie, right? The person who's just kind of learning about EdgeX and wants to get it up and running. So our agenda today is going to be to, first of all, understand what EdgeX is. Why does it exist? Try and examine some of the tools that we are using to run EdgeX, not necessarily develop EdgeX. Development will be a topic for later agendas. We're going to focus in on the fundamentals of two tools in particular, Docker and Docker Compose, that we're using to orchestrate and deploy EdgeX. We'll look at how you get to those tools up and running and how you get EdgeX up and running with Docker and Docker Compose. We'll provide you some checks to see how EdgeX is running, to be able to make sure that it is running as per our instructions, and to give you a little bit of an insight as to the types of data and information that flow through EdgeX. And then we'll, again, provide some Q&A at the end to try and answer any questions that we haven't as far as our discussion today. So as I like to start off and explain EdgeX to people, there's a lot of information out there in the industry today about why IoT is hard to do, Internet of Things. And there's quite a few bits of information there, and I'm not going to go through every bullet on this slide. But the idea here is that IoT is really a kind of a postdoctorate in just about everything we've known or done in computing for about the last couple of decades at least, probably goes back 30 or 40 years if you want to consider a lot of the fundamentals. It brings together all sorts of different hardware in lots of different settings in operating systems. It brings together things in what are typically smaller and more constrained devices, things like a gateway, but it also encompasses clouds and everything in between, including those smart devices that we often talk about. And then deals with various types of protocols. Most of us are familiar with things like TCP/IP, but how many of you have heard of things like Modbus or BACnet? These are the types of protocols that things usually have to communicate over, and it requires us to get into those as well. If you're familiar with cloud platforms, there isn't a cloud out there that doesn't like to think about IoT as a means to start to collect all sorts of new data and deal with all sorts of new types of intelligence that we didn't before. So your Azures, your Amazons, your Googles of the world are all very much competing for your work and your money to try to host all of your IoT information and intelligence. Add on to that things like analytics and security and management, and you really do have a very complex world out there. So the way I like to try to introduce EdgeX then in regards to that IoT problem is that it is an open source vendor neutral approach to try to help simplify that IoT mechanism, that IoT PhD dissertation that we just described, at least at the edge. While we'll talk about how EdgeX can run from edge all the way to the cloud, it typically is focused at more of the edge where we see things connected and where we see things like gateways helping to manage those connected things. EdgeX is what we call a microservice-based architecture. For those of you who are software engineers, that might mean something. For those who are not software engineers, what that means is that we're talking about a collection of very small or minute applications that work together in a loosely coupled fashion, meaning they're not directly tied to one another, to provide for edge computing. And what does that mean? What is edge computing all about? Essentially the collection of sensor data, device data from those things that are out there in our world, the collection of that data, the management of the data and the devices that are providing that data, and then getting that data up into other environments where more intelligence can be performed so we can save money, we can actuate things like motors and doors and things of that nature based on what we find from that information. Now, EdgeX is also hardware and OS agnostic. We run on Intel and ARM. We run on Unix, Linux, Windows, Mac OS, you name it. Again, trying to be very loosely coupled in terms of hardware and software, as well as all the components that make up EdgeX. EdgeX is a Linux Foundation project, obviously the reason for our hosted call today, but it is also what we call Apache 2 license project. What that means is it's very business friendly. You can take EdgeX as an open source project, download the code, completely run off with it on your own, do whatever you'd like with it, fork it, decide to make an entirely different product out of it. It's all yours, all for just the price of going out to GitHub and downloading it and deciding to do what you want to do with it. Now, of course, we'd love to have you participate in part of our project to help improve it or to use it in some of your solutions and give us credit for it. But as Apache license is concerned, it really is one meant to be used and utilized as everyone sees fit. The goal of EdgeX, as I mentioned, helps simplify the IoT problem, really to help enable and encourage the growth of IoT solutions, which today we see being blocked a bit because of some of the complexity and because a lot of the common building blocks simply aren't there yet. So EdgeX is trying to provide for those simple building blocks that allow us to make IoT solutions from edge all the way to cloud a little bit easier. And do that with a community, meaning that we're really focused on things like interoperability, making sure that each of us are building blocks that work with one another. Plenty of room for adding value. Again, that goes to our Apache 2 license. Plenty of room to make a return on investment, again, with regard to the Apache 2 license. And where possible, trying to bring in the best of breed solutions. EdgeX actually uses a lot of other open source technology, but in the future, it could also take advantage of brand new modules that fit to the specifications that EdgeX have, but were never even conceived at the beginning, all because of this very loosely coupled, very platform independent architecture. So that's what EdgeX is. Our goals: build and promote a common open platform. This is a pretty important statement when we say platform. EdgeX itself is an application, but it really more is about a platform or framework for building edge computing solutions, meaning that, well, it's probably going to give you maybe 80 to 90%, we hope, of what you might need for some of your solutions in your use case, but there's still going to be some work to do. There's still 10 or 20% out there, depending on how complex your use case is, where you might have to actually do a little bit of work yourself to provide for those final ingredients to get your IoT solution up and enabled. And we provide a certification process, or at least we're going to here in the future, to allow us to make sure that we really do have that interoperability and compatibility that we are looking for. Meaning that if you build a new component and you run it through our certification process, you can be rest assured that in the future it will continue to work and work with other components that are provided by others. That again provides for that platform independentness, but also the interoperability and that growth that we're looking for in this space. A real brief history of EdgeX. Dell started what was called Project Fuse at the time. Again, that was the project that I originally architected way back in July of 2015. So we're talking now more than 3 years ago. We offered the Project Fuse code into the Linux Foundation, donated our code back in April of 2017, so a little bit more than a year ago. And we had a pretty substantial amount of code out there. This code was primarily written in Java, and it really was more of a proof of concept than a final product. But over the past year, we've had more than 50 organizations. We had 50 founding members. Today, I think we're up to something like 70-some members that are participating and helping us to improve and productize, I'll use productize in air quotes there, EdgeX, to allow for that platform to kind of be something that many people can take and use as a foundation for their IoT solutions. We have a cadence that provides for 2 releases a year. We initially released our very first community release was back in October of last year, what we called the Barcelona release. We just got through with our California release here in June, and we're going to be releasing Delhi in October. You can kind of gather from the names here: Barcelona, California, Delhi, Edinburgh is going to be in April of next year. Kind of the ABCDE nomenclature that is used by groups like Android. So our releases are all kind of staggered by about 6 months, depending on what we have in a release. Try to do it 2 a year. And you will find out there in our wiki site a roadmap that indicates both what has been produced and what will be coming up in a future release. So that's our history and a little bit about why EdgeX exists. Now let's talk a little bit about how EdgeX works and obviously get you into a case here we can actually see it running. So there are a lot of words on this page, and I'm going to come back to the words in a second, but I often find that a visual is the best way to kind of talk somebody through how EdgeX does its work. So here's our kind of famous, maybe now infamous, I'm not sure, depending on your perspective, architectural diagram of EdgeX Foundry. Each one of these little boxes you see on the screen, for example, highlighting scheduling right now is one of our services. Each one of those represents a microservice, again, a little mini application that is loosely coupled and not tied directly to any of the other boxes you see on the screen. Each one has a very discrete job. And we segment the jobs in EdgeX essentially into 4 logical layers. Down here, what we call the south end, we have a collection of devices. Now, each organization's devices are obviously going to be a little bit different, but you get the idea. You have a group of sensors or devices that you need to communicate with, and you need to get their data up into other systems. The very first layer of services, microservice that we provide in EdgeX is called device services. And each one is tied to a particular protocol. It speaks, in other words, the sensor or device language. For example, there's a Modbus device service, and there's a Zigbee device service, and things like a BLE device service, if you're familiar with something like your phone that has BLE protocols associated with it. Each one allows devices or sensors speaking that particular protocol to be able to communicate its data into EdgeX. Once that particular device is, say, connected up to EdgeX through one of these device services, it can start sending its data. Say, for example, we have some sort of a temperature reading sensor out there, and it's reporting that the temperature of some sort of piece of equipment is 102 degrees Celsius, so quite warm. That data is then sent into the next layer of EdgeX services, which we call core services. And in particular, it sends it into what is known as core data. Core data is the service whereby that sensor reading is persisted, and that's why you have the little database sign there, and where that data is then made available to any other service inside of EdgeX, but also will ultimately be made available to anything that might be in your enterprise, your cloud environments that needs that data. Now, the important ingredient here is that the device service is going to communicate that data into some sort of format that everyone can understand. Maybe you don't understand BACnet or Modbus or whatever the protocol is. That doesn't matter. Device services will translate that into a nominal JSON format that then can be used throughout the rest of EdgeX and the rest of your enterprise. EdgeX data is then shipped up to one of our what we call export services at the very top end of our diagram here, and in particular sends that data off to what we call the distribution service. And it's the distribution service that's responsible for getting your data, the sensor and device data of your things, up into your enterprise, be it your on-prem server, say the cloud, maybe you're sending it off to Azure, wherever the case might be. And it knows how to communicate with the particular cloud providers of choice. It knows how to communicate with your on-prem system. It's been given instructions about how to do that. In fact, you have to actually register your various clients through our client registration service, and that allows EdgeX to then know how to get the data to your quote-unquote endpoint. But the distribution service also ships the data back down inside of EdgeX to another microservice we call the rules engine. Now, in fact, this could actually be a place for any what we call local analytics to be provided. EdgeX provides a rules engine by default, but if you have what we call edge intelligence or some mechanism that you want to look at the data coming up from sensors and make decisions, it would be hosted in this rules engine or local analytics box. So the distribution service gets the data coming up from sensors, from core data, to not only the clouds of the world, but also gets it to the analytics or the intelligence based at your edge, based in EdgeX. And then the analytics engine, or again, our rules engine, will communicate with what we call a command service. And that command service helps to translate your request for doing whatever might be kind of a nominal type of service, maybe stop this device or give me a new reading or whatever the case might be. And that command service translates that then back down through a device service, back down to a device or a sensor, in this case as an example, to stop that machine, maybe because the 102-degree reading is just too hot for the system to handle. So that's EdgeX in a nutshell. Now, there are a lot of other services you see on the screen. Most of them are pretty self-explanatory. Things like logging. Yep, they provide logging for the entire system. Or alerts and notification provide a means to alert somebody when something is maybe out of place or out of alignment with expectations. Something like metadata provides information about what is connected, where it's connected, and how things are connected to our EdgeX system. So lots of services working together essentially to provide this workflow you see on the screen. So how do we get EdgeX up and running in our environment? Well, actually, it's quite simple. We have built into EdgeX kind of 3 approaches to get up and running with EdgeX. If you are a developer and you want to maybe either contribute into EdgeX or you want to take EdgeX and extend it out into your use cases, then you're what we call a contributor. Maybe a better word for that would be a developer. And so there's a developer approach for getting EdgeX up and running. This is not going to be the topic of our conversation today, but it will be a topic of conversation in an upcoming Tech Talk. There's the user's approach. This is where you want to get EdgeX and you want to run it as is, and that's the approach we're going to look at today. We're going to take a look at using Docker and Docker Compose to download and get EdgeX and make it function inside of our environment. Again, that environment could be any environment you could think of. Typically, we think about EdgeX running on something like a gateway, an Edge IoT gateway, but it could run on anything. In fact, today you're going to see it running on my laptop. So that's the approach we're going to look at in terms of getting and running EdgeX today. And then there's a last approach, which is the hybrid approach, where maybe you're a developer, in other words, a contributor, and you want to get and run EdgeX to be able to do some development, but you don't want to have to work on everything. Maybe you're only going to work on a new logging service, and you only want to be able to develop in the code that's for the logging service, but all the other services you just want to use as they are, as they exist already out there in the EdgeX environment. Well, the hybrid approach allows you to get and deploy the containers, the parts of EdgeX that you don't want to change, while at the same time working on services that you do want to change. And again, that is an approach we're not going to cover today, but it'll be covered in upcoming tech talks. By the way, there are older tech talks that you'll find out there in our wiki pages. We'll talk to that later on today as well. Some of those tech talks can approach at least the topic with some generic ideas. Some of the specifics which have changed over the past year from those original tech talks are things you're going to have to kind of work around until we get some of these new tech talks created. Now we're going to use a tool called Docker Compose to get and run multiple what we call containers, Docker containers, with our user approach today. If you're not familiar with Docker and Docker Compose, don't worry, hang on. We're going to talk about that here in just a second. So in particular, what is Docker? Well, Docker is a tool that you'll hear a lot of the development community talking about, not just with regard to EdgeX, but really across the world. And what this is a bit like a virtualization environment. In other words, it provides a layer across, say, for example, your operating system that allows for all sorts of packages to come and run without you really having to worry about all of the ingredients being built into your environment. So Docker provides the ability essentially to package up and run an application in a very loosely environmentally independent way. And we do that with something we call a container. Think of as a container as all the bits that you want to run packaged up so that it can be deployed to some sort of environment out there. In fact, be deployed to what we call a Docker environment out there, or a Docker engine, maybe a better way to put that. And you can host many containers simultaneously on any given host. So if you think about virtualization, what virtualization allows you to do through something like a hypervisor is it runs on top of the OS, but then you have to load up your own guest OS and then your applications and binaries on top of that. Docker helps to simplify that a bit. Docker runs on top of the operating system, so we have a Docker engine that runs on top of an operating system like Windows or, say, Ubuntu Linux, and then your apps and your binaries are all packaged up as containers, and they run on that particular engine. Allows you to take advantage of some of the ingredients that are already out there in your infrastructure, and not having to always provide your own guest OS out there makes deploying these things much smaller, lighter, and usually faster than having to do things in some sort of virtualized environment. And oh, by the way, it makes it a lot more platform independent, again, with regard to running these various containers, and that's how EdgeX today is able to run and span multiple environments. Other than that, you really don't need to know much about Docker. In other words, you typically don't have to get into all the gory details about Docker. Just know that it's a mechanism for us to run various bits out there on your infrastructure. Behind the scenes, our development team take all of the bits, all the code and everything that makes up our particular containers, and that will include some of our program artifacts. We run Go today, so there's Go artifacts. Maybe you're running Java, and it would be the JVM, along with things like configuration and any other kinds of libraries or ingredients to make the particular services run. They put those through a process called Docker build. That creates Docker images. It's those Docker images that help create the actual containers that we pull down and run in our environment. So a lot of work goes in behind the scenes of making this EdgeX environment work, or make any Docker application work. But the important part in the end is, as a user, you're looking to get a hold of the containers that make up EdgeX, and those will run in your infrastructure. Now, Docker Compose is a tool that helps us orchestrate or work with many of these particular containers. In other words, where if you went to Docker and you got one of the EdgeX containers, that would help you run one little box like we saw in our diagram before. Unfortunately, EdgeX is several dozen of these types of containers. And so what Docker Compose does is it allows us to what we call orchestrate, or work with and run multiple containers at one time. So this is what allows us to run many microservices pretty darn quickly, as we'll see, with a set of tools that Docker Compose provides to not only get the containers, but then also get them up and running. So when we talk about getting EdgeX from a user's perspective, the first thing you're going to need to do is make sure that you have Docker and Docker Compose set up in your environment. So there's some instructions here for where to go to how to get Docker. In particular, you're going to want to get what's called the Community Edition, which is a free and openly available edition of Docker. And Docker Compose, which is available at a slightly different website, as you'll see here. Although if you're running Windows or if you're running Mac, the nice thing about Docker Compose is it already comes with your Docker install. So if you do a Docker install, you'll get both Docker and Docker Compose. If you're on a Linux or a Unix type environment, you'll have to do these two installations a little bit separately. Now, I'm going to make the assumption here that with the instructions and the links provided on this page, you will have no difficulty in getting and running Docker and Docker Compose. If that's not the case, feel free to communicate with me or our community. Happy to get you up and running with Docker and Docker Compose. It's pretty typical that even in a lab environment, I've been able to get people up and running somewhere between 5 and 10 minutes with these two tools, depending on the speed of your internet connection. So it's really not a difficult task. Just follow the instructions there. Be careful of some of the notes that you'll see inside those instructions, and it won't be any time at all before you have Docker and Docker Compose running in your environment. Now, as I mentioned, we're taking the user approach today to get and run EdgeX. And so what does that mean? Well, EdgeX is provided a set of Docker containers already. Again, those images that I mentioned that allow all of those microservices to run without you having to deal with any of the code. This provides a real convenience. The question then is, well, where do we get these various containers? They're made available in what's called Docker Hub. This is a repository the Docker community has set up. It's at hub.docker.com. It allows us to pull down all of those containers that are part of EdgeX. Now, inside of our project, inside of our Linux community, we also have a local repository. It's called a Nexus repository, where the same images can be found, but this is really more for the developers to use as we're making changes kind of on a daily basis. Typically, it's the hub.docker.com place we want to go to actually get the containers for our use in a user environment. So let's go take a look. I'm going to pull up a browser here real quickly. And if we go out to hub.docker.com, like I've done right here, and if we just did a search for EdgeX Foundry, we'd actually see all of the containers, all of those images, I should say, that make up EdgeX that are available from hub.docker.com. Now, as you can see here, there are 49 repositories. There are 49 images, if you will, from which to choose. So getting all those and making them available and getting them up and running, well, that's where the complexity is. But wait, we've provided a mechanism to help simplify that, and that's what the next part of our discussion here is going to be. And that is to use Docker Compose to help simplify getting and running an EdgeX. Yes, you could go out and actually manually pull and download and start all of those EdgeX containers. It first of all require you to have some pretty sophisticated knowledge of Docker. It would also require you to do things like set up a network inside Docker and something called a volume. You'd have to know about how and when to start all those containers. We've simplified that by providing you what's known as a Docker Compose mechanism, or what's called a Docker Compose manifest file. And that manifest file allows you to, with one command, pull down all of EdgeX, and then with another command, start all of EdgeX. And you'll see these are pretty simple commands. That manifest is essentially a mechanism that dictates to Docker and Docker Compose the order in which to pull things down, all the infrastructure to get set up and allow you to run EdgeX, as well as all the mechanisms to set up things like networks and ports and things of that nature, so all these containers can talk together. Now, what does a Docker Compose file look like? Well, it is what's called a YAML file. So it's a markup language file. So it's not always the easiest thing to read, especially for non-developers. We're going to take a look at one here in a second, just so you get a sense of what it's all about. But as I mentioned, as a manifest file, really what it does is it just lists out which containers that need to get pulled and run, in what order, and how to set them up in what's called a network. And that does address some complexities, things like ports and such that they run on, but all that's hidden from you as a user. All you have to do is use that manifest file to instruct Docker and Docker Compose to get and run our containers. So I've provided here a little section of the Docker Compose YAML file for our EdgeX environment. Let me bring up the entire file here just so you get a sense of what it's about. As I mentioned, what the Compose file does, it lists our services. For example, it lists things like volume and our configuration and registry service, things like our database, which is Mongo. Then we get into some of the actual EdgeX services, things like logging. We saw that on a slide. All it does is says which particular image from Docker Hub we want to download, what port we want to assign it, where we want it to run on our network, in this case a network we've called EdgeX network, and then some of the dependencies and the volumes and other bits and pieces necessary to actually get any one of these containers up and running. Again, these are details that as a user you don't need to worry yourself about, but if you did want to have an understanding of what exactly is being pulled down and what exactly is being run, it's all right there in that Docker Compose file. Okay, now back to getting EdgeX up and running. So now we have an understanding of what Docker does, what Docker Compose does. We understand that there's this Docker Compose file that specifies what we need to actually get, download, and pull in a manifest file to get EdgeX up and running. How do we do that? Well, there are a series of commands that run Docker Compose in a command line tool fashion that pull, or if you will, download EdgeX, ones to run EdgeX, what we call up, and then additionally commands to stop EdgeX if you need to stop it, or to restart it if it's already been pulled but you need to restart it after you've stopped it, and even means to do a little bit of debugging. So things like logging to get back the logs from any one of our microservices. So to get EdgeX up and running, given our Docker Compose and giving some of those commands, it's really a one-line call, one command line call to pull or download all of the EdgeX Foundry containers necessary to run EdgeX. And then to start, or at least to initially start EdgeX, we need again one line command, and that is the up command. So let's go take a look at this in action. I've got my command prompt here, or my terminal window, I guess, whatever you want to call it. And this this particular terminal has Docker Compose already installed. So if I did something like Docker-V, I get the version that's out there. What I'm going to do now is ask for Docker Compose to pull EdgeX. And what this is doing is it's reading the Docker Compose file that's right there in that same directory, and it just went out and it pulled all those particular EdgeX repositories from that Docker hub location that I showed you before. By the way, that operated really quickly, didn't it? And that's a little bit of a misguidance here in that it would take probably about, a couple minutes to pull all those containers. I had already pulled them just previous to this talk, so you wouldn't have to sit and wait for the pull to get done. But it will download typically with a pretty good internet connection in under 5 minutes, but not seconds as you just saw. In fact, what it did there is it just checked to make sure that it had the latest versions of all my containers before we get ready to do the next run command here, which is exactly what we'll do next. We'll ask Docker Compose to start and run EdgeX, and that's done with the Docker Compose up -D, and -D just tells it to run in kind of a non-sticky way. It's going to actually start processes as opposed to try and run that right here in the command prompt window. So as you can see, it's now asked every one of those containers that is part of EdgeX to start up and run itself. Fantastic. So now we have EdgeX downloaded. We have EdgeX running. So there are a lot of containers in EdgeX. Do I need to know all about those containers in order to understand how EdgeX works and what's going on? Well, I provided kind of a list of the containers that are being downloaded and some of their jobs. As you start to get into EdgeX a little bit more, and as you start to understand all of its various functions, then knowing a little bit about each one of the microservices and how they work and how they work together to provide the ultimate solution that I showed you is important. But to begin with, just starting to get our arms around what EdgeX does collectively and understanding that there are various services that are going to provide some of these duties, as you see here, is good enough to get you going. Once you get into the details of either development or you start to get into the details of trying to specialize EdgeX for your particular use case, obviously the jobs here are going to need to be looked at in a little bit more detail. With regard to EdgeX 2, there's also infrastructure that underlies all of EdgeX. You won't see everything listed completely in the Docker Compose file, in that manifest file. For example, you will see some shared file space that EdgeX used. That actually is in the manifest file, something called a Docker volume. You would see the Docker database. We use MongoDB by default as our persistent store. We use something called console, which is provided by HashiCorp as a mechanism for registering and configuring all of those microservices. Again, these are details as a user you don't need to know all about, but it is important to understand that even beyond the code that the EdgeX community has written and provided to you through those containers, there's additional ingredients that are working as part of EdgeX underneath the covers. So typically what we see in any kind of EdgeX deployment is, again, all of those containers that are part of EdgeX, things like core data, metadata, command that were on that diagram, they're all made part of a network of Docker containers, as well as some of the infrastructure. Again, things like the database are part of the infrastructure that makes EdgeX work, but they're all linked in together into a common, what's called Docker network. And you can think of a Docker network just like you would think of a network of computers. The only thing is it's virtual. It's built out of this virtual environment that is Docker. Now, if we wanted to, we could stop EdgeX right now by just issuing the command docker compose stop. So if I went back to my command prompt, that would stop all of the containers, would stop any kind of action from occurring with regard to those containers. If you want to actually stop and remove EdgeX in all the containers, maybe you realize there's a new version of EdgeX and you want to get rid of the current containers we've got, then just call docker compose down. So again, this is what makes the use of Docker Compose so simple for users. Really, there's only a handful of commands one needs to get, start, stop, and even remove all of EdgeX. Once you start to learn more about Docker and Docker Compose, you'll find out there's all sorts of additional commands that are out there, from checking status to being able to change various pieces of the infrastructure. But for now, that's enough to get up and running. So, trust me, it all works. It's all there. It all is operational. That probably sounds a little fishy to you. And how do I know it's actually doing what you said it's going to be doing, Jim, with regard to dealing with sensors and devices and getting all that information available to my enterprise? Well, in fact, once you've got EdgeX up and running, we can provide you a number of checks which are listed here on the page, which will, A, show you a little bit about that stream or workflow that I showed you with regard to how data comes through EdgeX, and B, allow you to check to make sure that EdgeX is actually up and operational as we said. The very first thing we can do here is we can go out to check EdgeX's registry service to make sure that the services are all up and running as we expect. If we go out excuse me, if we go out to where EdgeX is running and go to port 8500, we can actually see the user interface for that particular registry. And this is it. So I know it's probably a little bit tiny to see on your screen out there, but I'm again at port 8500 on the actual machine that EdgeX is running right now with all of my containers up and running, as you saw. And what I'm seeing here is a little UI provided by our configuration registry service. And what the configuration registry service does is it, as every service comes up in EdgeX, it registers that service as running. So as, for example, we talked about core data. As core data comes up, it registers itself with the registry service, as does every other service. Include even things like our infrastructure, like the database, Mongo, is also registered into our registration service. So this is a great way, just going to the 8500 port on the machine that's running your EdgeX environment gives you a quick status that all the services are up and available. By the way, this service also provides us information about all the configuration for any particular service. So we actually go and see all of the information about how EdgeX is actually working with regard to some of the configurable elements out there. But that's points of discussion that get into a little bit of detail that we'll go into at a later point in time. With an indication that all of our services are up and running, the next thing that we may want to do is actually test out some of our services and see a little bit of things running. For example, we can actually go out and take a look at the logs from any particular service. Docker compose logs -f, --tail, a number of log entries you want to see, and the actual service that you want to see them coming from is a way to do that. So real quickly here, let me go back out to my command prompt, and I will, somewhere in here, I had that command already stored. There we go. Let's take a look at, say, the last 100 log entries into core data through Docker Compose, and there we see them. We see that information is being put in there about various events, which are readings as far as the EdgeX system is concerned, being placed into the core database. And you can see it's actually live and running as it's actually spewing out data as we watch it. What else can we see with regard to knowing that EdgeX is up and running? Well, we can actually ping any one of the services. The ping operation allows us to actually hit a REST API that's associated with each service and get back some sort of response to know that it's actually up and running. Now, you will need to know the port that each of the services operates on, and that's listed in that Docker Compose manifest file, but then just call on the ping API for each one of those to see it running. So let's take a look, and I've got my favorite tool to actually engage various REST APIs. It's called Postman. It's a free tool that you can get out there on the internet. And I'm going to go to port 48080, which is the port for core data, and ask to ping that particular service. And when I do, I get back a response of pong. That ping pong is a typical request response we'll see for every one of the services. What else can we see? Well, we can see the actual data being collected from a set of sensors and devices. In fact, we can get a count of the number of readings that have been read by EdgeX for any particular device or sensor. Now, when we're talking about EdgeX today, in this environment that we're running as kind of a user here with no real physical sensors attached, what we've done in our EdgeX community is develop something called a virtual device that mimics a real device. And by default, when you run Docker Compose up, you're going to get that virtual device to mimic devices actually associated to your EdgeX environment. So when I go out today and I ask for the system, oops, wrong postman there. When I ask the system to give me the event count, what I will get, if I fire that off, is a number of readings. In this case, 17,970 readings, or what we call events, have been collected off of that virtual device. Now, the virtual device is actually mimicking things like a thermostat and a motor. We can actually see the actual devices being emulated in our EdgeX environment by going to another API, one called the Device API. And the Device API gives us a listing of JSON that is the actual devices that are associated to my EdgeX instance right now. And in particular, one of these devices is called a KMC BACnet thermostat. At least that's what it's mimicking in this particular environment. And if I want to actually see readings from that particular device, I can call on another API, in this case an event API, for that particular device. That's why we see the device name in that API. And I'll ask for the last, well, let's change this. We'll ask for the last, say, 15 readings off of that particular device. And what we see there are pieces of information coming back off that device. In this case, some analog value had a reading of 93.2. That's probably the temperature reading. As we scan down there, we'll see other analog values associated to it. In this case, 48.37 is probably an indication of some sort of humidity, or at least simulated humidity for this BACnet thermostat. So now I've got a real indication that EdgeX is not only up and running, but I'm actually seeing examples of the live data coming off of a virtual device into EdgeX and being managed by EdgeX as our whole system is now operational. So that's pretty much it, folks. Again, a list of various checks, but also examples of how to start to exercise EdgeX. We'll take on, as part of one of our other upcoming tech talks, more information about all of the APIs that are associated in EdgeX and how you can really start to dig into the details of what EdgeX is doing underneath the covers and how your use case and your particular use of EdgeX can be made available to start to work for your IoT solutions. To be fair, Docker and Docker Compose is one of the favorite deployment mechanisms we have for EdgeX, and certainly from a user perspective, now hopefully you see how simple and easy that is. But EdgeX is agnostic with regard to deployment and orchestration, meaning there are other ways to get and run EdgeX. In fact, members of Canonical in our community have provided what are called Ubuntu snaps. This is a mechanism that's similar in some ways to Docker for the Canonical environment. We have other members that are using tools like Portainer to get and deploy EdgeX. And you could certainly use something like Kubernetes Swarm or Mesos if you had a larger type of machine to run EdgeX on, to both get, download, and orchestrate EdgeX up and running. So we believe EdgeX is what we call a BYOD, bring your own deployment mechanism. And you could even run EdgeX outside of any kind of containerized tool as well. You could run them straight on the native OS, so long as you compile them correctly to that particular OS. So while Docker and Docker Compose is a great way to get things up and running in the initial stages, you may choose to deploy and get EdgeX and run it in different environments based on your particular deployment mechanism of choice. And that's okay. We believe that is also part of the flexibility of EdgeX. Lastly, some project links that you're going to want to know about. We are a project that's hosted out in GitHub. That's where you can find all the code. You can find our technical documentations at docs.edgexfoundry.org. And our wiki is located at wiki.edgexfoundry.org. So we try and keep things pretty simple there. And in fact, you'll find a lot of the technical videos to include these tech talks out there at that particular location you see on your screen. Lots of connection points, too, for things like our blogs, our email, and Rocket Chat. Rocket Chat is very much like our, what would you call it, a media mechanism, like some of the others that you might have used out there online, like Skype chat or something of that nature. So if you need to send somebody a quick message inside of EdgeX, great way to do that. And again, we're on all the social media mechanisms as well. Lastly, my email address is here again, gang, james_white2@dell.com. We got about 16 James Whites inside of Dell, so make sure you put the 2 there. Otherwise, somebody's going to get very frustrated in my company. And we've got other upcoming tech talks that I'm going to turn it over to Michael to discuss.
All right, so I hope everybody's enjoyed this tech talk, and thank you, Jim, for running it. We will get to the questions in just a minute. We do have some more of these talks coming up. In the works so far, we're going to have an API walkthrough, a little bit more detailed than what Jim presented here, going through the whole process and showing how the various APIs between microservices work, so you get a real good low-level understanding about how EdgeX works. We're planning on having a talk on creating a new device service. Jim mentioned some of the ones that we do support right now, but EdgeX is made to support anything that you might come across. So if you've got a specific protocol or way of talking to a device that doesn't already have a device service, you can create your own, make that work. And the same thing for the export services, that northbound side where you send it up to your enterprise or your cloud for analytics or additional processing. So we'll have some more in-depth walkthroughs on those. And we're open to any other suggestions. So if there's some aspect of the project that you're interested in having a tech talk on, please let us know. We will try and find somebody who can give that presentation and get that on the schedule. We plan on doing these, like I said earlier, every 2 weeks as time permits. October is going to be a bit of a busy month for us. We're going to be in Barcelona for IoT Solutions World Congress, and then we're in Edinburgh for the Embedded Linux Conference. So we may miss a date there in the middle of October somewhere, but we will try and do these as often and as regularly as we can. All right, so if anybody has any questions, again, you can ask them in the group chat window. If you don't have that open, there's a little button at the bottom of the screen that shows the slides right now where you can open that up. Or you can just unmute yourself and go ahead and ask the questions, and we will get to as many of them as we can.
And I do see, Michael, a question from Ram. It says, we're trying to understand how EdgeX works and also MainFlux. I see that EdgeX and MainFlux are working together. How are these two solutions complementary to each other? Are they not very similar to each other based on architectural diagram of EdgeX and MainFlux? Yeah, great question, Ram. And the answer to your question is yep. EdgeX is an open source effort, as is MainFlux, and MainFlux is a member of our EdgeX community. if you would like, the way to really kind of think about it is MainFlux is building kind of on top of EdgeX. In other words, they're using EdgeX to help facilitate and get data into MainFlux, and then MainFlux can trigger applications, another piece of environment that might use that data to perform actions inside of your environment. So EdgeX is serving as kind of part of their infrastructure. They also offer a mode where EdgeX doesn't have to be there. Just like any good architecture, they want to be decoupled from other elements, and so you can decouple MainFlux from EdgeX and use it in different ways or with other infrastructure below it. But the idea is EdgeX helps feed MainFlux when those two are working together. Hopefully that answers your question, Ram. Any other questions that are out there?
And this is actually a really good segue into talking more about EdgeX as a platform. So as Jim mentioned, we try and do 80% of the common things that everybody is going to need to do. Everybody needs to get data from devices up to some beefier service that's going to do something with that data. But nobody wants to reinvent that wheel. So EdgeX Foundry is a neutral platform for these different companies to come together to work on that common bit of infrastructure so that people who make devices can just concentrate on making devices. People who are doing analytics based on IoT data can just focus on the analytics platform. Companies like Dell who are building the hardware to power these things can focus on that hardware. And everybody comes together on this common platform so that we don't have all these different competing standards locking people into one vendor or another.
Thanks, Michael. Any other questions? All righty, hearing no other questions
later on, or if you're watching this as a recording and you didn't get to make it to the live session, you can always join our Rocket chat. That's chat.edgexfoundry.org. There are people on there 24/7, really, depending on their location. We do have members from around the world. But I'm active on there. Jim's active on there. If you have any questions, feel free to jump on. You can ask them there. And we look forward to having you all back next time. That would be September the 18th at the same time, so 2:30 p.m. Eastern time. I think it was 11:30 a.m. Pacific time. So look forward to having you then. We will announce the topic for that one, hopefully about this time next week. So keep an eye out for that. Again, follow us on Twitter at EdgeX Foundry. Join our newsletter at the bottom of our webpage. All right. Thank you, everybody, for coming. We'll see you next time.